Okay, so section 104 word problems. Here is your first example. Please go ahead and write this down. It says the following. Actually, I think I'll type it out for you guys. It probably will be easier. It says the sum, I'll make this bigger by the way. The sum of three numbers is 20. The first number is the sum of the second number and the third number. Don't worry about copying this down. I'm going to resize it and everything right now. And the third number is 3 times the first number. Find, all numbers. Okay, let me resize this, make it look nice. And let me make this bigger. There it is. Yep, so here is your example. A little bit bigger. The people in the back. There it is. So once again, it's the sum of three numbers is 20. The sum of, the first number is the sum of the, I forgot to write this down, the second number. This should be second. Okay, go ahead and write that paragraph down. Wait, yeah, you can go ahead and write it down. You're good. All right, we're gonna start in about 30 seconds. So finish writing the sentence down. Yes, sir. The first number is the sum of the second and the third number, and the third number is 3 times the first number. They're two separate statements. Yeah. So I'm saying like the first number is the second and plus the third, and then I'm saying the third number is 3 times the first. We'll write a statement right now, like a equation. All right, are you guys ready? Okay. How many numbers do we have in total? We have 3 numbers, right? We are told that the first number is the sum of the second and the third, which means that there's 1, 2, 3 numbers total. We are going to let x, y, and z represent those 3 numbers. So why don't we begin with the following. Let's let x equal your first number. We will let y equal your second number. And we will let z equal your third number. Okay. So that's the first thing is letting variables represent those ideas or those concepts from the statement that we were given. Right. Now let's make our first equation. But actually, we're gonna start to also extract important information from the paragraph. So let's begin with the very first sentence. What does the first sentence say? Who can read the first sentence for me? What does the first sentence say? Go ahead, write it. The sum of all three numbers is 20. Think about what that means. The sum of all three numbers is 20. So, what operation can we assume is happening between all three numbers? If it's a sum, it's what? It's adding. So we're saying we have the first number, the second number, and the third number, and what do they all equal? 20. Okay, so this is your first equation. The sum of three numbers is 20. That's the first thing that we're told. Okay. All right. The next thing we're told is that the first number is the sum of the second and the third number. Once again, the first number is the sum of the second and the third number. So what is the first number? The first number is what letter? X, Y, or Z? X. We're saying X, the first number is equal to the sum operation. What operation would that be? Adding the sum of the second number, which is Y, plus the third number, which is Z. Okay, so now we have two equations. Okay. And then just for reference, I'm highlighting like the equation so you know which one corresponds to what statement. All right, finally, we are told that the third number is 3 times the first number. So the third number is 3 times the first number. What do you guys think 3 times means? Are we adding by 3? We're multiplying by what factor? By 3. It's 3 times multiplying by 3. So the third number, which is Z, is 3 times, so 3 multiplying with the first number, 3x, 3 times x, right? So we're going to have these 3 equations. All right, how do we feel about this so far? All we did is just set up the equations, and that is from the information that was given to us. So keywords like sum, you know you're adding. If you see anything like bigger than by, like 3 times bigger than such and such, or 4 times bigger, or 2 times bigger, that all refers to multiplication. Okay. All right. So how do we go about solving this this problem then? Well, here's the thing. We have a 3 variable system of equations. So this is review of 102, right? And with when you have 3 variables, you want to set it up so that you can cancel out one of the variables, right? So the strategy when it comes to solving a 3 variable system is to solve it through elimination. And the only way that elimination works is if you can get rid of some of the variables altogether. So essentially what needs to happen is we need to write, I'll do it over here to the side. We need to write the equations in x, y, z form. So we're gonna kind of mimic the structure of the first one. Notice how the first one is x, y, z. X plus y plus z equals 20. So we want to have, essentially what you want is you want all the variables on the same side. You want to set it up that way with all the variables on the same side so that you're able to eliminate. And so what that looks like is the following. You're not going to do anything to the first one because it already has all the variables on the left side. But the second one, we are going to move things to one side. We could move the x to this side, or we could move the y and z to the side with the x. Which way would you guys like to do? It's going to be the same thing anyway. Is there a preference? Or should I just go for it? All right. So if I want to move everything to the same side, personally, I think it would be easiest to just move the x. So like we have x equals y plus z, right? So why don't we just, subtract x from both sides? And then we'll have 0 equals negative x plus y plus z. And I'm rearranging them because I want x, y, z form, meaning like the x first, followed by the y, followed by the z. All right. You are able to move things around as long as you keep the signs the same. Sure. So we start with x equals y plus z. And the goal is to get all of the variables on the same side. I have two variables on the right side already. To get everything on the same side, all I need to do is move the x. To cancel the x on the left, I have to subtract it from the left. And I subtract it from the right as well. And then I have everything on the same side. Okay? Are we okay with that? All right. Then we will repeat the same with z equals 3x. I could move the z, or I could move the 3x. It really doesn't matter. I think I'll move the 3x. So I'll move it by subtracting 3x from the right and from the left. That's how I'm able to move terms around. We okay with that? So it's going to look something like this. We'll subtract 3x from here and 3x from here. And then that'll give me negative 3x plus z equals 0. Okay. So this that I'm boxing, these are like your new rewritten equations. Okay. And I'm gonna put everything in a single system in just a second. Okay. So I did a step on here that's different from the notes. We're gonna find out if we get the same answer. Because in the notes they move the z first. Mathematically, it doesn't matter which one you move. So so just bear with me. We're gonna find out if there's any changes. All right. So once you have written it in x, y, z form, then we can kind of set up our system of equations, which is like what we would have seen in 102. So let me write that right here. You zoom in. Now write your system. And so our system had the following. It had x plus y plus z equals 20. That was the first equation we came up with. X plus y plus z equals 20. And then we came up with negative x plus y plus z equals 0. And finally, we had negative 3x plus z equals 0 as well. You will notice that we have kind of like this missing value underneath the, next to the 3x. If we don't have any y's, what can I write in its place? How many y's do we actually have? If we don't have any, we don't have, or what number would we use to denote no y's? It would be 0, right? So I'll write that as 0y. And it's just a placeholder. Like, it's just so that it's not empty. Just don't forget to put a plus like I did. Plus 0, 1, like that. So this is like our new system. Okay. And so this is going to be pretty much review of 102, because once we get to this point, we have to do our process of pairing up. You have your A, your B, and your C. Yes, question. As a placeholder, you can't leave it as just y, because in our when we solved for this equation earlier, there were no y's. The equation for this was simply negative 3x plus z. So we just can't write a y because there's none in there. We're just writing 0y as a placeholder just so that it's not empty. But it's not. You could leave it blank if you feel comfortable leaving it blank. Like I said, I'm just writing the 0y so that you don't get confused and accidentally move other variables. All right, so at this point, this should be sort of a review. Let's see if you guys are ready for your quiz on Friday. You're gonna label this A, this one B, and this one Z. All right. Okay, what do I do next? Remind me. I'm gonna have you guys help me out from here on out. What do I do next? Riley. Make the pairing A and B, B and C. So that's gonna be A and B right here, and then B and C on this side. So let's start with A and B. So A was x plus y plus z equals 20, and negative x plus y plus z equals 0. That's A and B. Okay. All right. Is there a variable that you guys would like to start eliminating already? X. You'll notice that X would probably be the easiest one to get rid of since we already have it set up that way. Just remember, whatever variable you choose to eliminate from the left side from this pair, you have to do the same on the other side. All right, just don't forget. So I'm going to write it here just so that we know we're eliminating X. All right, let's see what we get. So this is going to cancel out. We'll be left with 2y plus 2z equals 20. 2y plus 2z equals 20. We'll come back to this a little later. Are we okay with this first pair? We're all good? Okay. Let's go to B and C. So B was negative x plus y plus z equals 0. And then we said that C was negative 3x plus 0y plus z equals 0. Okay. Now, because we are choosing to cancel out the excess, then I need to find myself a common multiple between 1 and 3. So what am I going to multiply the top by? Negative 3. Negative 3. Very good. So the reason why I multiply by negative 3 is because I want these x's to cancel out. So this is what's going to happen. I'm going to get positive 3x minus 3y minus 3z equal to 0. Second equation is not going to change. Second equation will stay as negative 3x plus 0y plus z equals 0. And this is the one we're going to solve for now. All right. So let's evaluate. Do you need the top still, or are you just good with this part? Okay. All right, great. So we're going to start by canceling out the x's. 3 minus 3 goes away. We get nothing left over. Negative 3 plus 0 is negative 3y. Negative 3z plus z is 2y. Negative 2, I'm sorry, negative 2z. So we get this remaining equation. Negative 3y minus 2z is equal to 0. Okay. All right, so far we have isolated this down to two variables. We have canceled out the x's, and we have a new system. And this new system now only contains two variables. So this is going to be kind of like 1.01. How do we solve a two-variable system of equations? Well, you're going to take these now. Take these now, and we're going to make a new system. Right? Make a new system, which will be 2y plus 2z equals 20, and negative 3y minus 2z equals 0. This is going to be your new system. And it actually sets itself up nicely, because you can kind of already look at what we're going to cancel out. The z's, yeah. So if you're looking ahead, you'll notice that 2z and negative 2z will be able to cancel out. We actually don't have to do any other steps except just combine. So are you guys ready to combine, or should I wait? We're good? Okay, so 2 minus 2z, that's going to cancel out. We'll be left with negative y equals positive 20. Once again, negative y equals positive 20. Is that our final answer? Can I leave it as negative y? No, I have to technically divide by negative 1. And so that's going to yield the following answer. Is going to give us y equals negative 20. Once again, y equals negative 20. And that's good. We just solved for our first variable. Now it's just a matter of kind of working backwards. Okay. All right. So now that we have y equals negative 20, we're going to take that value of y and plug it into one of these two that we just kind of got from our new system. Do you guys have a preference? Would you guys like to do the first or the second equation? First equation. So 2y plus 2z equals 20. We'll do it over here. 2y plus 2z equals 20. Right? I replaced the y with the negative 20. That's what we said y was equal to. So we said y was equal to. Okay. Ready for the next step? All right, we're going to distribute 2 and negative 20 makes negative 40. Negative 40 plus 2z equals 20. And then that's just a two-step equation. Give me the first step. What's the first step? Add 40. We're going to get 2z equals 60. 2z equals 60. So what next? Divide by 2. Great. Now we found two of our variables. Now we know y and we know z. y is negative 20, z is 30. Okay. Last step. You guys ready? So earlier we had said that z, remember in the beginning, z was equal to 3x, right? Z was equal to 3x. So if z is equal to 3x, and we just found out that z is 30, then what will x equal? If I have 30 equals 3x, then how do I solve for x? What step do I take to solve for x? Divided by 3. And so x is going to equal 10. And now we're done. We've just found all of these values. We found the value of x, we found the value of y, and we found the value of z. Okay. All right. How do you feel about that example? Yeah? It's too early though. I can't give you a break yet. Yes, question? So this was from the original, our very original setup, when they told us that the third number is 3 times the first number. So we came up with z equals 3x. That's I used this equation basically. I could have used any of them to solve for x. I could have used any of the equations here. I just chose to do that one. I thought it was the easiest one. Okay. So there are 2 more examples. I'm going to give you guys one more example, and then we'll take a break. Then we'll do the third example, and then the quiz. Sound good? The quiz retake. Yeah. All right. The next one should be easier though, so let's get through that one. All right. So second example. Write this down. Second example. All right. Let's see. Who can I use as an example from this class? Who would like to be part of this example? The name. Give me a name. Ella. All right. So let's say Ella is remodeling her house and she wants to paint her room. What's your favorite color, Ella? Blue. So let's say she wants to paint her room blue. Ella bought 7 quarts of paint. Yeah, 7 quarts of paint. We have X amount of quarts at $3 each. That 3 slash QT, that means $3 per quart basically. So we're saying she bought X amount of quarts at $3. Let's say that that's from, I don't know, Home Depot. And then we have Y amount of quarts that she got from, let's say, Lowe's. At $2 per quart. Let me fix this so it's not running away. There it is. This is what we want to find. We want to find out. Find X and Y if the total cost was $16. All right. Let me give you and your team 10 minutes to. Well, actually, that's too much. Let's do 4 minutes to come up with a system of equations. Yes. No, you're not gonna solve it. I just want you to come up with your equations. All right. You have 4 minutes to come up with your equations. Go ahead and get started. For my millions of followers. All right. So keep in mind, there's two types of quartz. We have X quartz that are Home Depot or whatever store, and the Y quartz that are like Sherwin-Williams or Lowe's or whatever. Altogether, there's how many quartz total? 7. So we know that it's the sum of whatever X is and the sum of whatever Y is, and it makes a total of 7 quartz. That's the first thing. That's the first equation. That altogether, all number of quartz makes 7 quarts of paint. That's your first equation. The second equation is going to relate to the cost. All right. Second equation is the cost of each quart and how it relates to the total. So we're saying that whatever X is, it costs $3 per quart. And whatever Y is, it costs $2 per quart. And altogether, the cost is $16. All right. 7 minutes to solve this, you and your team. Okay, your last example is the following. Let's write this down. I'm going to type it out for you. The perimeter of a rectangle is 34 inches. If the length is 2 inches more than twice the width, find the length. Oops. Twice the width. Find the length and width of. Actually, just find the length and width. Let's get it. Yep. So once again, the perimeter of a rectangle is 34 inches. If the length is 2 inches more than twice the width, find the length and width. I'll walk you through this one, don't worry. Yeah. No, because you only are looking for length and width, so that's only 2 unknowns. All right. So let's have you guys finish writing this down, and then we can start. By the way, this stuff, 104, is not going to be a super big portion of your guys' test. Okay. Word problems are very complicated, so you might only see maybe like 1 question on the test. We won't really go too far in depth with this. Okay. So let's begin by understanding 2 things. Well, 1 thing. We have 2 unknowns, so we can expect a 2-variable system. That means that if we have 2 unknowns, that means we have X and we have Y. So if we have X and Y, then let's let X equal the length. And we can let Y equal the width. One more thing we need to establish before we even begin doing any work here is understanding the following. What exactly is perimeter? So area is when you multiply the outsides of a shape, but perimeter is when you add them all together. So let's say we have a rectangle, then the perimeter would be, we're saying x is the length, so that's x and x right here, and y is the width. X, x, y, and y. And actually the perimeter is the sum of all of these sides. So I'm going to write that over here. Let me zoom out. The perimeter is the sum of all sides. Okay. And you add x and x, y and y. All right, so we can actually go ahead and start making our first equation. We're told that the perimeter, the perimeter of the rectangle is 34 inches. So the perimeter of the rectangle is 34 inches, then that must mean that when we add all the sides together, we get what? 34. So if we're adding everything together, then we have x plus y, and all of this is equal to 34. Okay. X plus y, and all of this is equal to 34. Yes. We're going to do that next. Yes, we're going to combine like terms. We're going to rewrite this as 2x plus 2y equals 34. And I'm going to highlight this to let you guys know that this is our first equation in the system from the first sentence where we were told that the perimeter was equal to 34 inches. Okay. All right. Now here comes the next part, and this is the complicated one. We're told the length is 2 inches more than twice the width. Once again, the length is 2 inches more than twice the width. So x is the length, right? Let me write that over here. So the length, which is x, if it's 2 inches more, is that times 2 or plus 2? Plus 2. So it's something plus 2. 2 inches more than twice the width. Twice. If it's 2 times, is that? There you go. 2y. And this is from second equation. All right, what method, what strategy do you anticipate we're going to use to solve for these variables? Elimination would be kind of complicated. Substitution would be easier because we have already solved for x. You're going to have 4 minutes to complete this problem.